Okay, lecture 3 is all about the solution making and the important solutions in the biotech industry, such as buffer solutions and growth medium. Okay, so solutions. Why are they important in the biotech industry? Because they are used a lot during the cell growth process or during the API purification process. There are a whole bunch of solutions with different content, and they are used to protect the integrity of the API, active pharmaceutical ingredients. Okay, so you got to know how to make solutions, how to prepare them, and then how to treat them if they have to be sterilized. Okay, first of all, how you make solution. So there are different ways of making solutions. Okay, but one of the way is you have to dissolve certain amount of chemicals or the chemicals, which is the solute, within a defined amount of solvent, so that there will be a defined amount of total volume. So the mixture of the solute and solvent will give you the total volume. So the ratio of those two, solute per the total volume, will be the concentration. Okay. So among the different ways of making solutions, first way is simply you can describe how much of solute you need within a total volume, which is solute plus solvent. Okay, so you can be given with the instruction like this. You need to make a 50 milliliter solution of an enzyme called protease K, but that concentration should be 2 milligram per mil. Okay, so then how do you make this solution? So this concentration says in every 1 ml of this solution, enzyme solution, you need 2 milligram of the enzyme itself. Okay, but the amount of the solution you need to make is what? 50 ml total volume. Okay, so you need to basically what? Multiply 50, because what you need is 50 mils, right? So 50 times the concentration will give you the amount of enzyme you need. Okay, so that's straightforward. So in every 1 ml you need 2 milligram. So if you're making 50 mils, of course you need about 50 times of 2 milligram, which is 100 milligrams. So 100 milligram, what are you going to do with that? You will have to dissolve that enzyme in how much of water, for example? Is it going to be just 50 mil straight? No, it'll be less than 50 mil. Because 50 ml is the total volume, which is the combination of enzyme and water together. So you may use about 45 ml of water and mix them up, the enzyme and water together, and the total mixture will give you the final volume of 50 ml. So you need to adjust the final volume to 50 ml, right? And how about this question? Can you do it on your own? Okay, you need to make 100 microliter of this solution. The concentration is every 1 ml you need 100 microgram. Okay, in this case the concentration is higher than what you need actually, so it's 1/10. Okay, since it's 1/10, you need 1/10 of 100 microgram, so it is 10 microgram. Of course, it makes sense, right? Do the same thing here. The concentration is 2 milligram per mil of sodium chloride, but you need to make 50 mil. So how much of the sodium chloride you need? Of course you need 50 times, which is 100 milligram. So you need to dissolve that in, again, less than 50 mils, so about 45 mil, and mix them up. Once it's completely dissolved, do the final volume check. Straightforward, right? And the second type of solution you need to make is called molar solution. So define what a mole is. 1 mole equals there's a certain number of atoms present. What is the number? 6.02 times 10 to the 23 number of atoms present within that given amount. Right? So each chemical, each molecule has a different molecular weight. Okay, you need to find out what that is. If you look at the chemical equation, you can find it out. And their masses, and you combine them all, that's going to be the molecular weight. Okay, you can do that if you have a periodical table, or you can look at the bottle that has the chemical in it. Normally, the bottle has the molecular weight or formula weight written on them. So, for example, this copper sulfate, its formula weight is 159.61 gram. Okay, that will give you that many atoms, right? So if you're asked to make certain molar solution, for example here 1 millimolar copper sulfate, you need to make 1 liter of that. How do you figure out how much of the copper sulfate you need? Okay, so 1 mole of copper sulfate, for that you need of 159.61 gram. right? But what you need is not 1 mole. Instead, how much? 1 millimole, which is 1,000th of 1 mole. Okay, so you need to multiply all those. Molar concentration in mole. Okay, so since it's 1 millimole, that'll be converted back to the mole. So 1 over 1,000th mole is the concentration, and times the molecular weight, which is 159.61 gram per liter. Okay, and then how much of that do you need? The final volume you need times 1 liter. So you multiply the molecular weight, okay, times the concentration in moles and the final volume you need to make. Okay, so that will give you, if you do that, you get 0.156961 gram per 1 liter of the volume. So that'll be the answer for that. Here's a little tricky question. So the question is, if you're making 1 liter solution, and how many micromoles are there in 17.4 milligram of NAD? Okay, NAD is a chemical. Okay, so if you have 17.4 milligram of NAD, and if you dissolve that in 1 liter of solution, okay, what will be the concentration of NAD? That is the question. It turns out the molecular weight of the NAD is 663.4 gram per every mole within 1 liter volume. Okay, so if you want to solve this question, you need to match the unit, of course. So milligram should be converted back to a gram. So 17.4 milligram should be converted to the gram. So if you divide that by 1000, and you will come up with 0.0174 gram. So that's same as 17.4 milligrams. So if you dissolve that in 1 liter, what molar would that be? So in 1 mole concentration, you will have 663.4 gram of NAD. But right now, you only have 0.0174 gram of NAD. Okay, how much of that will be in mole concentration? So it's a kind of equation. So 1 mole per 663.4 gram, then 1 mole would that be in 0.0174 gram. So if you do the math, if you have a calculator, just do this quickly and solve for the m, then you'll find out it will be 0.000026228 mole, which is, if you convert that into a micromole, it's a 26.2 micromole. Okay, simple conversion, math conversion. That's what it is. So if you are asked to make a molar solution, the way of doing that is you multiply them all. Okay, so molecular weight, gram per mole, 1 mole per liter, and then multiply that with the molarity in mole. Okay, and then volume in liter. So the important thing here is you need to match the unit. Okay, so of course there is per liter. Okay, so if you multiply them all, you'll figure it out how much of the solution you need. Okay, so the question is, how much solute is required to prepare 300 ml of 0.8 molar solution of calcium chloride? The molecular weight of calcium chloride is known to be 111 gram per every liter of water. Okay, so it's the gram there. Okay, so then again, what do you need to do? You need to figure out the molecular weight, which is 111 gram per 1 mole per liter, and then what is the concentration you need to make? It's 0.8 mole per liter, of course. Okay, and then how much of that you're going to make? You need 300 ml, which you convert it to a liter. 300 ml, if you convert it to a liter, it's going to be 0.3 liter. So if you multiply them all, you figure it out, it's 26.64 gram. Okay, so that's the answer. Okay, do the practice using this question on your textbook, page 499. Okay, and the third solution making method will be using a percentage solution. Okay, so percentage is what? How much of the solute is dissolved in 100 ml volume of the final solution? That's the percent. Okay, it could be the solute per solution, or it could be a volume of the solute per solution. Depends on how your chemical will come in. Is it going to come in as a powder or liquid? Whatever that is, it's per every 100 ml of the solution you're preparing. Okay, so let's practice using this question. So how do you make 500 ml of 5% solution? 5% is what? 5 over 100. Okay, so in every 500 ml you need 5 gram, but you are making what, 500 ml, so just multiply 5. That's simple as that, right? 5 times 5%. So 5% is 5 over 100, okay, times 500, and you can figure it out. That's 25 gram. That's easy, very straightforward, right? So that's how you calculate it. Okay. How about this? How do you make 100 ml of 10% solution by volume solution of ethanol? So ethanol comes in a solution, not the powder. So since it is coming in a solution, it's going to be the volume per volume. Okay. So if it's 10%, that means 10 milliliter per every 100 ml of 10% solution will be made up with ethanol. Okay. So then you want to need so that answers it. You need just 100 ml of 100% the pure ethanol and dissolve in 100 ml of the final solution, so which is about 90 ml of water that should be added there. Okay. How about this question? How would you make 5% of 500 gram of sodium chloride? But in this case, it's going to be weight per weight. Okay. So in every 100 gram, you're going to have 5 gram of sodium chloride. Okay, but you have 500 grams, so it's 5 times more. So 5 times 5 gram is what, 25 gram. Straightforward, right? Okay, so the last case is, how about dilution? What if you have a already made stock solution that is very much concentrated? You're asked to make a dilution out of it. How do you do that? For that, you need to remember this equation. Okay, Ci times Vi equals Caf times Vf. Okay, in that case, C equals concentration, I equals initial, okay, V equals volume, I equals initial, F equals final. Okay, here the C and V means the same thing, concentration and volume. So in this case, initial is the stock, okay, concentration and stock volume, and the final is the what? Final the solution you are making, its concentration and volume. So if you multiply them together, you will solve for the unknown amount of the stock solution. Okay, that's how I figured it out. Let's practice. How do you prepare 100 ml of 1 molar solution of tris buffer from 2 molar stock of tris buffer? So what you already have is a 2 molar stock solution of tris buffer, right? From there, you need to dilute it to make 100 ml of 1 molar solution. So in this case, CF is 1 molar, right? And BF is 100 ml, okay? And then so 1 molar times 100 ml, that's same as we have the stock solution concentration, which is 2 molar. 2 molar times how much of that do you need? You don't know. It's a VI. Okay. So you solve this equation for VI. Okay. Then what? 1 times 100 divided by 2, which is 50 ml. So you need 50 ml of 2 molar stock solution. Then what are you going to do with that? You have to add water to dilute it. How much of water? Probably about another 50 ml of water. If you mix them together, you're going to have a 100 ml of 1 molar solution. That's how you're going to make this solution. Okay, straightforward. So when you make solution, so the solutions may be made with number of multiple things. Okay, so if you look at the page 515 of your textbook, there are multiple recipes that shows you different ingredients that are mixed up together. For example, TE buffer. Okay, you already have done the lab, is made up with the tris and EDTA together. In the TE solution, you have tris existing at 10 millimolar, but EDTA exists at 1 millimolar. So how do you figure it out? So whatever the ingredient is, that is the final concentration. So you have to calculate each component, okay, at a time and to find out how much of the volume of a tris unit. Same way with this EDTA, its final concentration. Okay, and find out how much of that you need. It depends on how much volume you need. Okay, and then mix them up and add enough solution until it's dissolved, and then check the final volume after that. That's how you do it. Okay, take a look at your textbook to understand the general procedure of solution making. Okay, so you have to figure out how much of the solute you need, and then add enough solvent to dissolve them, and then once that's done, you need to do the final volume check. And the grade of purity of the different chemicals, you need to figure it out, and the documentation required for your solution making. Take a look at the lab manual, the textbook.